Okay, so in this question, we have to prove that 1 factorial plus 2 factorial plus 3 factorial all the way till n factorial is not a square for n bigger than or equal to 4. So just a quick recap, what is the factorial first of all? So m factorial is given by m into m minus 1 into m minus 2 all the way till 1. So it's the product of the first m positive numbers. Okay, so let's deal with this question. So a very good strategy to use in these kind of questions is to see what's happening in the very first special cases. So let's just start plugging in values and see what's happening. So when you put n equals to 4 in this, you get un is, I should say u4. So you get u4 is equal to, well, let's see, 1 factorial plus 2 factorial plus 3 factorial, that's just 9 plus plus 24, because 4 factorial is 24, so 9 plus 24 is 33. Okay, but what is u5 then? U5 will be 33 plus 24 into 5, which is 120, which is going to be 153. What will be u6? U6 will be 33 plus 120 plus this thing into 6, which is going to be, well, 720, which turns out to be the same thing as adding 720 to this guys. So so 3 and 7 and 8 and so on. So one thing which you notice is that you will always get a multiple of 10 from now onwards, which means that you are always going to have the units place being 3. But unfortunately or fortunately, no square actually has the units place as 3. You see, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, and 6 square is 36, 7 squared is 49, and 8 squared is 64. Okay, 9 squared is 81. And obviously 0 squared is 0. Okay, so, well, first of all, you notice that all these units digits, they are always of some particular numbers only. These can only be 0, 1, 4, 9, 6, and 5, I think. Okay, and then if you want to go further, maybe let's go to 10 squared. Well, 10 squared can be written as 10 plus 0 squared, and you will notice that if we expand this uh, by using the a plus b square identity, you're going to get a squared, which is 100 squared, sorry, which is 100, or just 10 squared I should say. 10 squared plus 2 into 10 into 0 plus 0 squared, and notice that this thing will always be a multiple of 10. So finding the remainder of this thing when you divide this by 10 is the same thing as finding the remainder of 0 squared when you divide by 10. Similarly, for 11 squared, the units digit is the same thing as 1 squared, so the unit is the same thing as 1 squared. And then for 12 squared, the units digit will be the same thing as 2 squared, and so on. And so if you're given any number, for example, if you're given 336, maybe then if you want to find the units digit of this number, you just have to find the units digit of, you have to find the unit digit of 6 squared, which is 36. Okay, so that clearly tells us that this number, this 1 factorial plus 2 factorial plus 3 factorial all the way to n factorial, this will always have its unit digit as 3, but 3 is never the unit digit of a perfect square. So that's it. That's how you solve these kind of problems. And notice that for n less than 4, you still do get some perfect squares, right? So you get like 1 and then 9, and yeah, these are the only perfect squares. So yeah, this question was nice. I will see you in the next one.